So continuing on in our unit on collecting data, we're going to look at types of data today. And what we want to be able to do by the end of this lesson is to recognize and describe the different types of data, the different classes of data that you can collect. So first thing to divide these two into are probably qualitative and quantitative data. Okay? So quantitative variables or quantitative data are anything that can take on a numeric value. So the example that I've listed here are your midterm grades. This might be something like, an 89% is a numeric value. Something like, we might say like a size 4. If we ignore the size part, as long as we can represent it by a number, we have got a quantitative variable or something that is numeric. Okay? Now, if we have numeric or quantitative data, we often divide it into two categories. And we've talked about these two categories before. We've talked about discrete data and we've talked about continuous data. So discrete data are either finite, there are a fixed number of possible values, or there are, we could say, gaps between the various values. So it's possible for us to have something that can only be measured by integers or whole numbers. So numbers like 1, 2, 3, and 4 are okay, but something like 1.5 is not okay. Okay, so there's a gap in between 1 and 2 which we can't have any values for. Continuous data, on the other hand, have none of these gaps in between them. Okay, and they can potentially always be infinite. Okay, so this means that you can get arbitrarily close to any value. For example, anything that you're measuring with real numbers. And from the last couple of units, we usually had examples of discrete data that occurred when you were counting something. I think the example I gave last unit was you were counting the number of cars. Okay, whereas for a continuous, you usually cropped up when you were measuring something. Measuring some length of time or something like that. Okay. One little, what shall we say, a subtle distinction between the two. Sometimes when we have data in which there are gaps between the values, but these gaps are very, very small compared to the values that we're measuring, we treat the data as continuous even though it is technically discrete data. So as an example, let's say we are measuring somebody's age. Okay? If we are measuring the age in years, we might end up with values like 16, 17, 18. Okay? We would in that point say that, oh, this is discrete data. Because when people answering the question, they're saying I'm either 16 or I'm 17 or I'm 18. And we're answering this as though there are sort of big gaps between them, a gap of an entire year. If, on the other hand, we were measuring, so we would consider this, I should say, as discrete. Okay? Without the question mark, let's just say discrete. Whereas if we said, what is the age of somebody measured in days, well, we might get a number something like, 6,000 days. Or we could get 6,001 days or 6,002 days. We would probably then be more useful to us to think about ranges of ages. So 6,000 to 6,199 days. Or a range of ages from 6,200 days to 6,339 days, or something like that. Sorry, 99 days. Okay. So in that regard, we might regard this as continuous data. Okay? Because our gaps are a gap of 1 day relative to something that we're measuring somewhere up there in the thousands. Okay? So a little bit of a subtle distinction between discrete and continuous data. So our two types, we've talked about quantitative data here. What about qualitative data? Well, qualitative variables or qualitative data are things that have to be described using words. Okay? We can't represent them using numbers. Another term for qualitative data is categorical, because we're often just dividing things into different categories. Okay? So these can be of two types. we often refer to what are called ordinal categorical, okay? And these are variables that have a natural ordering to them, even though they're expressed in words, okay? So an example here is, let's say you're doing a survey and you ask people, how much do you like the Windows operating system? And you gave them a list of options, not at all, don't care, or I like it a lot, okay? Even though this is qualitative data, or categorical data, there's a distinct ordering to it, okay? You would always put not at all as sort of the least, and I like it or I like it a lot as the most. Okay? We'll contrast that to what is called nominal categorical. This is a thing that doesn't have a natural ordering to it, okay? So it is only divided into things that we can just sort of represent with a name, hence the term nominal, okay? So you might do a survey, you might ask somebody, what is the operating system on your computer? And they might answer with something like Windows or Mac OS or Linux or something like that. These are just names that we have given to these things, and there's no reason to put them in any particular order. Okay, so this would be nominal categorical. So generally, when we are dealing with qualitative data, we tend to end up with more bias in our survey, as opposed to when we have things that can be measured numerically. Now, what is bias? Bias is something that we're going to be talking about a lot in the next couple of lessons, but basically it is anything that, we'll say, skews your results. So we want to avoid bias in our data collection or in our surveys whenever we can. Okay. Now, finally, two other terms that we're going to encounter when we're working with data are what are referred to as aggregate data and microdata. Aggregate data is when you have taken a bunch of individual results or individual scores and combined them all together into a single summarizing number for an entire group. Okay. Microdata is the original data that you had before you did all of that combining. So it is going to contain every single record or every single response from your survey. So for an example here of aggregate data, I've listed the unemployment rate for Hamilton for the month of March was 5.8%. So they have taken all of the data that they collected to try and measure the unemployment rate, and they've put it together into this one number, 5.8%. Okay, and it represents everything they know about employment in the city of Hamilton for that month. What would the microdata be that corresponds to that aggregate data? Well, the way they measure unemployment is they send out a bunch of surveys to a sample of households, and they ask, are you employed, are you not employed? This is called the household survey. They also send out surveys to businesses asking, you know, how many people did you hire in the last month? How many people did you fire in the last month? How many total employees do you have, et cetera, et cetera. And this is called the payroll survey. So if you took every single one of these household surveys, every single one of these payroll surveys, and you put them in a big pile, that would be your microdata. Okay? Whereas if you take the information you get and you combine it into the unemployment rate, which is what you're trying to measure, that is aggregate data. So do you want to work with aggregate data or do you want to work with microdata? Aggregate data is a lot easier to work with because all of the analysis has been done for you. But you're limited in that the only thing you can do with that aggregate data is what that analysis has been designed to show you. Okay? The only thing that you get out of this number for the unemployment rate is the unemployment rate in March. Okay? If you wanted to do a slightly different kind of analysis, you would have to then go to the microdata, where you might have some additional information in there that you want to pull out. However, you're going to have to do a lot of work on that microdata to get it organized, to get it analyzed in order to get the data that you want. So microdata supports a lot of different kinds of analysis, but it's a lot harder. Aggregate data has already been analyzed for you, but it's only really good for that one piece of information coming up.